Imagine you are asking your company's internal AI assistant a very simple, everyday question, like, how many days off do I get per year? If you try to build this system by simply dumping your company's internal documents into a standard database like MySQL, it fails almost instantly. Traditional database architectures are rigidly designed around exact or partial keyword matches. They look for specific strings of characters. So if an employee asks for days off, but the official HR document is titled vacation policy, the system hits a blind spot. A traditional database lacks the contextual awareness to realize that those two distinct phrases represent the exact same concept. These legacy systems successfully store literal text, but they completely fail to capture underlying human intent. To build intelligent tools, we need a completely different architecture. The solution to this context blindness is the vector database. It relies on a process called embeddings.
Machine learning models take this text and convert it into a long, highly specific list of numbers. These numbers act as precise coordinates, plotting each word into a massive, multidimensional mathematical space. The core rule of this environment is proximity. Concepts with similar meanings are plotted physically closer to one another. Conversely, unrelated concepts are pushed far away into completely different sectors. Because of this spatial grouping, the database doesn't need to actually read the words to know they are related. It only has to measure the mathematical distance between them. The most powerful proof of this system is that you can actually perform mathematical equations on human concepts. A glowing node for the word king is plotted exactly at its multidimensional vector coordinates. Watch what happens when you subtract the coordinates for man and add the coordinates for woman. The resulting coordinate lands almost exactly on the predefined location for the word queen. Vector databases literally map abstract human ideas, like royalty and gender, as physical, manipulatable dimensions of mathematical space. The primary real-world application for this architecture is retrieval augmented generation, commonly known as RAG. Think of a standard AI model as a student taking a closed book exam. It relies entirely on static memorization, which often leads to hallucinated, incorrect answers when it forgets a specific fact. A RAG system is an open book exam. When you ask a question, the AI first translates your prompt into a specific vector coordinate. In this diagram, you can see the glowing user query node pulse outward to find the closest semantic documents in the surrounding vector space, feeding them to the AI so it can write an accurate, grounded answer. But there is a crucial technical guardrail. For this spatial retrieval to remain accurate, the source documents must be chunked into specific sizes, typically 300 to 500 tokens. Too large and you lose precision. Too small and you lose context. This spatial matching architecture translates every form of modern data, from audio frequencies to visual patterns, into the same mathematical language. Spotify uses this exact mathematical spatial matching to recommend new audio tracks to you, based entirely on your unique listening history. Pinterest converts room images into vectors to find similar decor, while cybersecurity systems cluster normal behaviors to easily spot distant anomalous threats. Vector databases provide the essential infrastructure bridge, translating the chaotic web of human meaning into a precise, calculated language that machines can navigate.